So guys, the question for today is bomb enemy. Let me read the question first, then we will solve it together. So given an m into n matrix grid where each cell is either a wall, an enemy or an empty cell, return the maximum enemies you can kill using a bomb. You can only place the bomb in an empty cell. Okay, so it is saying that we have three. This E enemies, E represents enemies, W represents walls, and 0 represents the empty cells, right? And we can only keep a bomb in an empty cell. The bomb kills the enemies in the same row and same column from the planted point until it hits the wall, since it is too strong to be destroyed. Okay, so if a bomb is kept here, it will destroy all the enemies in the current row and current column. That means it will destroy two enemies here. Let me just write it for better understanding. So if it goes, so 2, sorry. If the bomb is placed here, two enemies are destroyed. Now from here, what happens? Towards its left, it destroys one enemy. Towards its right, it destroys 0 enemies. Down there is wall, so it destroys nothing here. So in total, this place, if we keep bomb here, that this will destroy one enemy. Now what if we keep a bomb here? It will destroy all towards its down and all towards its left. That means this enemy and this enemy will get destroyed. So if we keep a bomb here, two enemies will get destroyed. What about here? If we keep a bomb here, this enemy will get destroyed, this enemy will get destroyed, as these are in same column. This enemy will get destroyed and this enemy will not get destroyed, because here if a bomb is blasted, there is a wall and it protects this enemy. So in this row only one enemy is destroyed, in this column two enemies are destroyed. So total 3 enemies are destroyed if we keep a bomb here, right? Now let us go move to the next empty place. Here also in this row one enemy is destroyed, that is this, and in this column one enemy is destroyed, that is this. So we will put here 2. In this there is a wall, so no enemy is destroyed this side. There is one enemy this side, so one enemy is destroyed. If we place a bomb here, if we place a bomb here, this enemy will get destroyed as it is in same column, and this enemy will get destroyed as it is in same row. So here two enemies will get destroyed and we will return the largest as 3, right? So what we are doing, we are transversing every element from beginning to end, right? We are transversing every element from beginning to end, and we are calculating if any element is present, all the enemies present right to it, all the enemies present left to it, all the enemies present down to it, and all the enemies present up to it, right? And we sum them all. For example, here we take all the elements up to it, down to it, left to it. And since we encountered a wall on the right side, so we stopped here, otherwise we would have taken this enemy also if we have not got a wall. So we transversed each cell in all the direction. Being here, we transversed in all the direction, and then in each direction we counted all the enemies in that row or column. So if there is a grid of m by n, then what we will get, transversing a grid that is m into n, and then for one for each of the grid, what we are doing, m plus n, rows plus column, we are transversing to each row and each column, that will be m into n into mn. This is a very huge time complexity and it will throw a TLE. Let me show you code for it. First of all, I did it intuitively, and this was my first approach, and it showed TLE. So initially I defined a res and I just returned that res. In between I did a BFS, that means transversing through each element starting from 0 0 and transversing till all, maintaining a visited set and maintaining a direction, then queuing it up and appending and visiting rows, columns, and then this is important, all that is BFS. And this here what I did was, I went to, if I encountered a grid where its value is 0, sorry, if I encountered a grid where the value of 0, what I was saying that count the enemy, and what I will store in the result the maximum of the enemies. So now let us see count enemy. What count enemy was doing, in a column it was first transversing this is transversing towards, sorry, this is transversing left, sorry, transversing up, since it's column it is transversing up, and in this column it is transversing down. Here it is since it is row, so it is transversing left and it is transversing right, and this code throws up TLE. The same reason, because we were transversing through each row and we were going up, down, left, right, and then we were adding everything up and we were finding the enemies on that column. So there was a huge TLE and it throws error. So let us see a very easy way to solve all this. I got this answer after going through tutorials, otherwise I didn't landed on it by myself. So let us take a huge example just to understand better. So here we can see that this is our grid. This is quite a large grid and it is of 8 by 6, and here all the empty cells represents a void. Let me just lock it, it will be better. So here all the empty cells become void, that is 0. All the enemies are green colored, and all the walls are this red pattern. All this red pattern represents this red patterns represents the wall. This green pattern represents the enemy, and the void patterns represent 0. That means all these are empty and we can put anything here, right? So now let us try to understand what it is saying. So it is saying that if a bomb is blasted here at this point, one enemy will get destroyed and no enemy will get destroyed because this enemy is hiding beyond this wall, right? So here one enemy will get destroyed, here no enemy will get destroyed. Alright, this is what I am saying. So let us just go and write here that one enemy is getting destroyed here, right? Just write one here. Now when we go to the next column, what we see that again one enemy is destroying, that is present here at 5. Again we are going to see that okay, here 3 enemy is getting destroyed. How 3? Towards its right, let us see, towards its right it is going to destroy this, and towards its down it is going to destroy all 2, but due to wall, sorry, in this row, in this column it is going to destroy these 2 enemies, but not this enemy because this enemy is hiding from this wall, right? So the total comes here as 3. Now go to next, this here, from this one enemy is destroyed to its row and one enemy is destroyed to its column, right? In this column one enemy, sorry, in this column one enemy is destroyed, and in this row one enemy is destroyed. So here again what we are going to say, 3, the 2 enemies are destroyed at this column, and in this column one enemy is destroyed, right? Yes. Now we move to the next column, right? We move to the next row, and here we will only see that how many let us just copy the rows from above only, because okay, just copy the rows from above, that is 1. All right, and we will count columns for ourselves. So no, just don't copy. We say that column rows. What is rows? Rows destroyed is, so let us here just bifurcate things. Rows destroyed was 1 and the columns were 0, right? Columns destroyed were 0. Let us say that this is row plus column. Okay, so we know that here 1 is at every point. So let me write this as this 1 plus 0, 1 plus 0. At every point of time we know that let us say like this, right? So we know that one row is destroyed, and in columns I will calculate every column differently. Just remove it from here right now. We are calculating for the first row, and for first row we found that row is 1, right? One enemy is present in this row which can be destroyed from here, and now we are taking columns. For columns we know that 0 here, 0 here as well. Here we saw that two enemies can be destroyed in this column. Here we see that okay, one enemy can be destroyed in this column, and here we see that 0 enemies can be destroyed in this column. Now when we move to the next column, we say that we need to calculate row, that how many can be destroyed here, but we don't want to calculate columns. Why? Because we already know that columns will be same unless we don't see a wall, right? So we are going here. We said that we don't know how many, we don't know the row how many enemies are hit in this row, but only one enemy is one enemy hits in this column. Next we go to next. I don't know how many row hit are there, but I know that in column 0 hits are there. And here I know that I don't know how many number of hits are there in row, but in column I have 2 hit. Since it was calculated above, but it was not mentioned, that's why I did it. Right? So this is the way how we do it. So let me just go to the column hit. Here we say that wall has come and nothing yet, so 0. Here we say that we have calculated 1 from left. Since it is not written here, so we are not taking it, so it's not doesn't means that it's not written, so we'll not consider it. Now we see that 1, I have seen 1 enemy till now in this row, right? Now for the next one, I am saying that I don't know row hit in this, but the total number of columns that are hit here are from above only 0. Now I don't know row hit in it, but the total number of columns that I get is, again I don't know. Why? Because I have just seen a wall above. In this column I have just seen a wall above me, so I need to calculate it from scratch. Now I don't know how many row hit are there, but I know that there is 1 column hit. Now here I don't know how many row hits are there, but I know that there is 2 column hit, right? Now let's calculate the number of hits in a row. So hit in a row is 1, hit in a row is 1, hit in a row is 1, hit in a row is 0, because it is coming after wall. So after wall I have not seen any enemies yet. So now we need to calculate this. So we need to here calculate the columns again. So here we see that in this, after this wall, in all this column I get only 1 enemy, that is this. So what I will be doing, I will be replacing this enemy by 1. Got it? So I will be just going and replacing it by 1, right? Now again what we are going to do, we are saying that I don't know the row hit here, but I know that the column hit is 1. Again I don't know row hit here, but I know that the column hit here is 2. I don't know row hit here, and even I don't know the column hits here. I don't know the row hit here, and even I don't know and I know column hit here is 2. Now let us calculate the row hits here. So row hits here are 1 that we can see in this row. I hope that you get that this is the one I am talking about. This one, right? Oh, sorry. I'm talking about this row, this enemy in this row, right? So again what we are going to see, that in this row I don't know the column, so row, so I have seen 1 here, and now next I don't know I know 1, column hit is 1, column hit is 1, row hit is 1, and what is column hit? in column hit I need to calculate this column again, because after wall I am seeing this cell for the first time, so I need to calculate it. So once I calculate it till the down, I can see that I can see 3 enemies in this row, right? So what I am going to do is I am just putting down here 3, right? Now I am going to the next row. So here what I get is, till now I don't know, suppose I don't know row hit and call hit is 1. I am just copying from above. I don't know the row hit here, but the column hit is 1. I am copying from above, right? Now what is the row hit here? The row hit is 1, right? And what is the row hit here? Since I am seeing this after wall, so I will need to calculate the row hit again. So the row hits again will be all the rows right to this wall. So rows right to its wall contains 2 elements, 2 enemies, that is this and this. So I will be saying 2 here, right? So it will be 2, right? Now let us move to the next, let us move to the next element and see that I don't know row hit, but I know that the column hit is 1 from above. I have seen it but not mentioned it since the cell is occupied, but it is calculated there. Assume that it is calculated there, and it is of course calculated there. When we will see in code and metrics, we will see that it is calculated there. So I don't know red row hit till now, but I know that the column hit is 1. I don't know row hit till now, and I don't know column hit even, because I have just seen a wall above, so I cannot copy the values from above. I don't know the row hit, I know the column hit is 1, and here I don't know the row hit, but I know that the column hit is 2, right? Now let us calculate the row hit. Row hit is 1. As you can see that this is the row hit 1, right? So what I am going to do, that I am just 1 1 1 1 and 1, right? Now here I don't know column hit, because I can't copy the column from above. What I need to do is I need to recalculate the values here, that how many of the enemies I can see in this column down from this cell. So it is 1, right? Now we will move to the next element. What it is, I don't know the row hit, but I don't know the column hit, and the column hit is 1. I am just copying from above. I don't know the row hit, but I know that the column hit is 1, copying from above. I don't know the row hit, but I know that the column hit is 2, copying from above. So row hit is 3 here, because I can see 3 enemies in this row and no walls. So I just calculate and I just replace everything, right? Now I am going to the new. I don't know what is the row hit, but I know that the column hit is 1, copying from above. I don't know row hit, but I know column hit is 1, copying from above. I don't know row hit, but I know column hit is 1, copying from above. I don't know row hit, but I know column hit is 1, copying from above. I don't know row hit, but I know column hit is 3, copying from above. Again, I don't know the row hit, but I know that the column hit is 2, copying from above, right? So now I know that the row hit is 0 here. I cannot see any enemy in this row, so I am just replacing all of these with zeros. And at the end of this node, I need to return the maximum value. So let's just replace 1, right? What we get here is again 1, right? What we get here is 1 plus 2, 3, right? what we get here is 2, right? What we get here is 1, right? Now next, what we get here is 0, what we get here is 2, what we get here is 1, what we get here is 3, right? What we get here is 1, what we get here is 2, what we get here is 2, what we get here is 2, right? Now again, what we get here is 2, what we get here is 3, what we get here is 4, what we get here is 3, right? Now what we get here is 2, and what we get here is 3, right? We get here 2, we get here 2 as well, we get here 2, we get here 2 as well, and again, no, we don't get here 2, we get here 3, right? Now here we get 4, sorry, here we get 4, and here we get 5, right? Here we get 1 1 1 1 3 2, right? Just let me 1 1 1 1 3 2, right? So this is what we get, and we need to return what we need to return. We need to return that where can we blast the bomb, the best place to keep the bomb so that the maximum number of the enemies is destroyed. So I need to return the maximum number of enemies that can be destroyed. So here, as we can see clearly, that the maximum number of enemies that can be destroyed is 5, right? And the place where I can keep it is 6 5. So at position 6 5, position is 6 5, position in the matrix is 6 5, and number of enemies that can be destroyed is 5, right? As we have seen that we are not calculating, we don't require to calculate and keep the matrix because we don't need to return the position. We are just required to return the maximum. We are just required to return this 5, the maximum number. So from here we can analyze that we don't actually need to return, we don't actually need to make this complete matrix. We can just create one column and we can update those as we see a wall. So after a wall, that column is updated, otherwise the columns values are just copied from the above. And in rows also we calculate rows, uh, and we just copy row to the next element, but as we see a wall we recalculate the row, right? So what we will be doing, we will be putting a row that how the columns varies, and we will be putting a column array to store all these values for each rows, right? So we have m into n, so we will have an n matrix for storing the column in a particular row, right? And we will have a row, for row we will be calculating it for each iteration, so there is no problem in that. So let us go to the code now and see that how to put. So okay, so this was the code for TLE. We will just, let us say that max killed enemies is result to this is 0 and return rest. So this is the first thing that we do anytime to get rows and columns. Right, so we get the rows and columns, and we need to calculate the rows hit, which is 0, and we need to calculate the calls hit, which is equal to 0 into number of calls. Right, now what we need to do, we need to iterate it through the complete array, complete matrix. So for r in range of rows and for r in range of rows, and for column in range of calls, right? So what we did was, we say that we saw there that if column was 0 or column was equal to, or the grid of row was same and one previous column was wall, so in this case what we were saying that row hits, we were resetting the row hits, and after resetting the row hits we were saying that for k in range c comma calls up to from that elements to the columns minus 1, what we were saying that if it is a wall, so if grid of rk is wall, so if grid of r k equal to wall, we will just break this loop, and otherwise if grid rk equal to enemy, so what we will be doing, we will be doing res plus is equal to 1, right? No, we will be doing row hits plus is equal to 1, right? Right. So what this is basically doing, let me show you once, that it is saying if column is 0 or the column minus 1 is 1 is W. So if a column is 0, that is here, or a column is if a column is 0, so this column is 0, so we will calculate everything. Or if a column is or if column minus 1, so for this row, so for all rows, if column is 0, we need to calculate everything, and for other rows, for this row, I only need to calculate the things from the left if I saw a wall before it. So I saw a wall before it, so I will recompute the row hits value here. I saw a wall here, so for this row I will need to recompute my row hits here. And that is true because the row hit here is 0 and the row hit here will be 1. Similarly here also, we can see that the row hit before this element, so it was 2, it was 1 here, it was 1 here as well, but after wall we need to reset this to 0, and then we will look at how many enemies we can see. The row hit is 0, the row hit is 1, the row hit is 2, so total row hit will be 2 here, right? So that's what this code is saying. I hope that this is clear. Now for next case, so if row equals to 0 or grid of row minus 1 column equals to W, then we will be saying that call hit let's say hits here, that better sounds. Call hit C equal to 0, and now what we will be doing for k in range r comma rows, same thing, I'm just copying it from above. The only difference will be, so this is row, so K will be row and C will be here. So K will be rows and C will be here. And one more difference, that in case of the row hits, we will be saying column hits, right? So this will happen. So what will this line say? It says if row is 0 or row minus 1. So if row is 0, where is row 0? Row is 0 here. So here I will calculate that how many column hits are in this row until we don't see a wall. If we see a wall, we will just break and write the count, right? Until we see a wall. If we see a wall, we will just break. And what if we see a wall? So if we so for this fourth row, if we see a wall before it, we will not be copying the column hits from the above. We will be recalculating it. Here we will be resetting it to 0, and then we will increment by how many enemies we see, right? So it is just resetting it to 0 and then counting the values again. So this is what this part of the code is saying. Now what we have to do is we need to know that if that grid is 0 or not. So if that grid row column is 0, so if that's the grid row column is 0, so what we will be doing, we will be calculating the total hits, and that will be row hit plus column hit. And we will say that res is equal to max of res comma total hits, right? Now let us just run this code. Okay, I got a runtime error, but why? I was not expecting it. So I am saying that if column is 0, oh my god, I did a blunder. So what's the call set? Okay. Okay, let me just submit this solution. And this solution is pretty much good. And what is the time and space complexity here? So we can see that the time complexity here is order of m into n, that is grid length. So for amortized analysis we can just ignore this, right? So I think that the time complexity here would be just order of m into n, and the space complexity will be order of mn, all order of columns, that is n. Yes, and what about space complexity? Yeah, order of columns, that is n. Yeah, correct. So this was all about this question. So if you guys like this solution, please hit a like button, and if you have any doubt, do write down in the comments. Do support me guys. Thank you.